In this video we're going to look at pipe materials. In the previous video we looked at the different types of systems, the stormwater, the wastewater and the water system, and each one of them has different requirements, which mean there are different pipe materials that are more suitable for each. So let's look at the three different types of pipe materials used for pipe systems within infrastructure. So you've got concrete pipes, which concrete pipes are PVC, otherwise known as UPVC, so that's ultra high density polyvinyl chloride, or polyethylene, also known as PE pipes. PVC or UPVC and polyethylene are both called plastic pipes, but they do have different properties. Concrete is very robust, very thick wall pipes, which means they can take a bit of a hammering, they can have vehicles running over top of them. PVC is thin-walled plastic, so if a truck or something runs over top of it, it'll crack. Polyethylene is also moderately strong, but it will also, if a truck ran over top of it, it'll collapse. The difference in failure between PVC and polyethylene is one of the differences in properties. The PVC will crack and break because it's a semi-rigid pipe. The polyethylene is a flexible pipe and it will crush as opposed to crack. Concrete pipe is really heavy, which means that it's delivered in 2.44 meter lengths, which is about 7 feet I think. It's heavy, so it has to be, even a 2.44 meter pipe needs to be lifted by an excavator. It's quite heavy. It can weigh, even a small diameter one can weigh 100 kilograms or something like that. So you need an excavator or a crane to lift it. On the other hand, PVC is relatively light. A 6 meter section of say a 300 millimeter PVC can easily be lifted by two people. It doesn't need an excavator or a crane to lift it. Polyethylene is a little bit heavier because it's a thicker wall, because of the applications that it's used for. It can come in 16 to 15 meter lengths. That 15 meter length there is the maximum length that you can put on a truck without having to have a special transportation permit, pilot vehicles and all that sort of stuff. So the 15 meters is not a restriction of the pipe, it's a restriction of the length of pipe that can be transported on public roads. And it's medium in weight. You probably do need, for most polyethylene pipe, you usually do need an excavator or something or a crane to lift it up and handle it. The jointing of concrete pipe is reinforced, rubber ring joints or sleeves. PVC likewise rubber ring joints or solvent welds. Polyethylene, because it's flexible, it can't have rubber ring joints because it'll just deform around it. So it needs to be connected together either through couplers or by butt welding, which means that the pipe, when it's connected, turns into one big long pipe, whereas these ones here, if you pull on a rubber ring joint connection, it'll come back out again. Once you've connected polyethylene pipe, it's pretty well stuck together. The applications: concrete pipe is really good for gravity systems, so wastewater and stormwater gravity systems. It can go to big diameters without too much concern about it being crushed. PVC is normally used for the small diameter gravity, so up to about 250 to 300 mils. The PVC pipe is better for gravity pipes than the concrete pipe. The reason why it's no good when it gets bigger is because it's a plastic pipe. As it gets bigger, it gets more liable to be crushed into an egg shape by surface loads. So as it gets bigger, it has to get much thicker wall to be able to resist those surface loads, and it starts becoming more expensive than what a gravity pipeline would be. Than what a concrete pipeline would be. A polyethylene pipe can be used for gravity, but the price of it is quite expensive. It is really used for pressure pipeline. It is very good for pressure pipeline because of its flexibility. It can take water hammer. Pressure's better than PVC. It can actually be snaked around. It's more flexible. It can be taken around curves better than PVC and concrete. So the rigidity: concrete is rigid, PVC pipe is semi-rigid, but mostly regarded as rigid. Polyethylene pipe is flexible, which means the polyethylene pipe can be turned around corners. So the radius, the outside diameter of the pipe, the radius of turn can be about 30 times the outside diameter of the pipe as a rule of thumb. So if you've got a 100 ml pipe, you can turn it around the 3 meter diameter circle. The weakness of polyethylene pipe is sulfide attack. If hydrogen sulfide is produced in, say, wastewater system, it mixes with water, it produces a low-grade sulfuric acid, and that can attack the concrete pipe. Although there is sulfide resistant concrete pipes on the market, they're a little bit more expensive and they're not as good as the plastic pipes at resisting sulfide attack. PVC and polyethylene, they're both liable to be degraded over a long term with with ultraviolet light. In other words, sunlight can actually damage them over the long term. It tends to make them more brittle. So they either need to be undercover or protected. Polyethylene pipe is got black in it to enhance its resistance to UV light, so it's not as bad as PVC. So looking at concrete pipe, you can see these quite large diameter. So these are about, that one there is about a what's that, about 800, 900. You can see that they've had to lift it in place. There are little lifting eyes on it. Those guys couldn't possibly lift it. You can see that it's all connected together. In this case here, they've used it to make an underground tank. And these ones here, they're using them to make a pipeline. You can see that it's got a bedding there, the bedding right around it. Not so important with concrete pipe, but you still make sure that you do it. You need that lateral support there. Just increases the resistance to external loads. If you get an external load on top of this, it does tend to crack it either on the top or on the sides there as it tries to form the shape of an egg. So you do need that lateral support and the proper bedding to support it. That support is even more important with UPVC pipes, which really need really good lateral support. So you need to compact the sides to make sure that it doesn't start to make the egg shape when it's got loads from the top here. So you can see there's plastic pipe there. You can see they've got a little wire along there, and normally they do that, or they put a tape there, magnetic tape, so that you can pick it up with meters from the ground surface. One of the great risks you've got with a buried pipeline is that you're not entirely sure where it is. One way of detecting it is to have a meter that detects detects steel, but unfortunately PVC pipe doesn't have steel in it, so it's all but invisible. So you put a tape or something down there so that the meter will be able to pick it up. As I said, it's connected by solvent welds or by rubber ring joints. So you can see this guy here sort of doing rubber ring joint connection. We'll talk more about that in a later video. Polyethylene pipe. So you can see that these big long polyethylene pipes there, you can see them sort of snaking around. They bend quite readily. Normally what you do is you weld them up, and you can weld them up into sections hundreds of meters long and then pop it into the pipeline. So you can see here they put this trench in, they welded all this up, and they put all of this in one go with a couple of excavators sort of lifting it into place. When you're transporting it round, you normally put it on little trolleys so it's not being scratched along the ground. One problem it does have is that it's soft and it's very easily scratched. So if more than 10% of the thickness of the wall is scratched away, then that pipe is no longer rated for the pressure rating that it had before, and you normally have to cut it out.